Hi everyone, welcome back. In this video, I'm going to talk about Numpy, especially about index, slicing, and reshape. So the learning objects of this tutorial is to understand index, slicing for one-dimensional and multi-dimensional arrays. We're also going to talk about Boolean Index and how we can reshape an array by using the Numpy Python package. So in order to do that, we need to load the library, which is by using command imports like numpy as np here. Second, we are going to talk about index and slicing. First of all, we talk about one-dimensional array in Numpy. Suppose that I have a temperature, artificial array of temperature, which is from 24 to 48, with the incremental step of 1. So when we print this temperature array, we will see that its values is from 24 to 47. Notice that this is the last value is 47 instead of 48 in this numpy.arrange command. So in the previous tutorial, I already mentioned if we using the numpy.arrange command, and for instance we print the value from 0 to 10. We only get the value from 0 to 9 because the Python using this numpy.arrange command in Python, it doesn't count for the last value in here. It's only go to the last value minus 1. So that's why we get the number 47 here. We can also print the shape of this temperature by using the temperature.shape, and the shape of this temperature array is 24. The reason why I picked 24 because the temperature just like 24 hours during the day. And of course, during the day, the temperature is not linearly increases like this. And in order to take out the first element of the temperature array, we can specify the number 0 inside a square bracket like this. So when we print it down, we get the number 24. We can also take out the last value by using the number minus 1, or you can put the number 23 inside the square bracket. So the return value will be 47. We can also take out the fifth element of an array, which is, well, for instance, 28 here. So we need to put the index is 4. The reason is Python starts from the index 0, so the fifth elements will be corresponding to the index 4. We can also take out the first two elements of an array by specifying 0 colon 2 here inside a square bracket. Also similar to the previous example, the last index doesn't count, so it only counts for the index 0 and 1 here. So if we want to take the temperature to the index number 2, including the index number 2, so the number here should be 3. We can also print out all of the elements inside this temperature array by specify only the colon from 0 colon 24 inside a square bracket. And we can also print out the temperature with a constant interval such as 2 or every 6 time step. So the number inside square bracket here corresponding for the first index, the last index, and the incremental step. So for this temperature array, it will print out the first value 24, and every 6 time step, it will print another value. For instance, 24, 30, and 36, and 42 in here. We can also print out the first 5 elements of an array by using the colon 5, which is equal to the 0 colon 5 if we put it in the square bracket. And we can also print out the last 5 elements by reverse the order and put the minus before 5 as specified in this command. previously we mentioned that we can print the value with a certain incremental step. We can also print in the reverse order with the incremental step of -2 or -6. So instead of going from 24 to 47, now it will go from 47 to 24. With here is 24 because with the incremental step of -2, and here is from -6. Okay, that is all we can have. We can use to take out the element or the index or the value in the one-dimensional array. Now we are going to talk about how we can extract the information from multidimensional array in Numpy. First of all, we will create an array, two-dimensional, N stand for column and M stand for rows. So in here, I specify the array, two-dimensional array 6 by 6. As you can see in this arrays, and the value in here is a little bit. We use the equation column equal column plus 10 times row. For instance, the number 1 in the first row corresponding to the row 0 and the column 1. So that's why when we put the row the value 0 here and column 1, we get the return value is 1. Similarly, for the second row, we have the index is 1. So this should be 10 times 1 is equal 10, and then plus 1 for the column. So that's why we get the 11. Number 11 here. So this is just about how we can create this array. However, the purpose of this section is to how we can extract the information from an array. For instance, in this command, in order to take the third column of this array, which is the column that I highlighting here, we can use the command and we put the inside the square bracket the colon and the number 2. The colon here means we take off the row, and then the 2 here is mean we want to take the third column because the index is starting from 0, 1, 2. So 2 will be corresponding to the third column. So that's why when we specify this and we print the value from the value will be from 2, 12, 22, 32, and 42, and 52, as we can see here. Similarly, if we reverse the order 2 and then colon, we can print the third row. So as you can see, the third row is in here. We can also take out the upper half of the diagonal block matrix like this 3 by 3 matrix by using this command. And we can also take out the upper right left diagonal matrix like 3, 4, 5 for this section. Similarly for the lower diagonal matrix. And so you can practice this by yourself. Okay, now I'm going to talk a little bit more about arrays. One of the common things that we usually have potential errors, that is we take out a section of a current array and assign it into a new variables. For instance, in this case, we have an array A, which is 6 by 6 here, and then we take a section of A, assign it into B. So, for instance, we take a inside section like this, and we assign it into B. When we print the B value array, you can see the corresponding values like this. This is okay. And then we assign a new value for this B array. For instance, you want to replace all of the values in here by the number 0. And then it's still okay when you print the B array. All of the values turn into 0, which is fine. However, if you print the value the array A again, you will see that the array A was modified according to similar as in B. So this is not good. It means that we modify the new variables. However, the original variables also being modified. So as another example, So now we have the of the value 0 here is corresponding to the B array, and then we take a section of B array and assign it into the variable C. So when we print the variable C, we shall see all of the value in here is 0, which is okay. And then we think that it is okay. I don't want the value 0 for this C array. I want to assign the value 99 for every element inside the array C. So it is still okay. And then when you print the C array, you see that all of the value here is 99, which is what you want. However, when you print the array B, you see that, oh, this time all of the value in B is not 0 anymore. This is being modified, especially for the section that you assign into C. So it was modified, and this is not what we want. So this is very important, because usually when we analyze the large data set, we didn't take a careful look in detail, so it can cause an error in our calculation. So in order to solve this problem, one of the ways that we can do is that we put the copy when we assign a section of an array to a new variable. For instance, we still have all of the value array B, which is all 0 value, but we put the copy when we assign to the variable C, so that when we have a B array a total 0 like this, and we print C, is also all of the value 0. And then now we assign a new value for the C array, for instance, number 1. And then we print C. We see that all of the values in C array is 1. And then we print B, which is original array of C. Then all of the value in B is still the same, 0. So this is what we want. Yeah, so just be cautious when we copy a section of an array and assign to a new array. We need to use the copy, or otherwise we can have some errors in our calculation. And we are going to talk about Boolean index. So in here we have I have an array A, which is from 0 to 1. And as we learned earlier, in order to take the third element of the array A, we put the number 2 inside a square bracket. So the return value will be 0.2, as you can see in here. So we can also specify a list of indexes to get a return value. For instance, here I have a list of 0 to 4, 6, which is corresponding to the value 0.2, 0.4, and 0.6 here. Sorry. And we can also return a logical array. For instance, let's say A greater than 0.5. So as every places in A where its value is larger than 0.5, it will return a true. Otherwise, it will return false. As you can see in this output, we can also return only the value of A instead of the logical values, such as and you can see in this command we have A and square bracket for those A larger than greater than 0.5. So as you can see, the value will be from 0.6 to 1. And here in this section of the code, I create an array. The first row in here is the index, and the second row is the value at the specific index. So now, for instance, we have indices 2, 4, 6 here, and we create a array B, which is a subsection of array A at the index 2, 4, and 6. So its value will be 0.6, 0.1, 0.9. As you can see, 0.6, 0.1, and 0.9 in here. So for now, for this B array, the first element is 0.6, and we would like to replace this value by another value. Let's say -9. We do this by assign -9 into the first element of B. So when we print B array again, we will see that the first element of B is -9. And notice that even we specify modify the value in B, it doesn't affect to the array A at all. So we can also, for instance, for those indices from indices 2, 4, 6, and if we replace that in A, so at those places the value will also be modified by -9. Yeah, and this is also similarly, we can also replace an array by -9 like this one. Okay, we go to the last section, which is about the reshape and resize. For instance, in here I have a data 1, which is a two-dimensional array, 3 by 2 column, 3 rows and 2 columns. So we would like to reshape this data into one single another dimension, let's say 1, 6. This means 1 row and 6 column. We can use numpy.reshape and data 1 and specify the dimension, the shape of the data that we want. We can also reshape into two-dimensional array become one-dimensional. For instance, in data 1 we have a 3 by 2. However, by using only reshape number 6 here, we can turn this 3 by 2 array into one-dimensional array. And alright, this is all done. Thank you very much for watching my tutorial. In the next tutorial, I'm going to talk about the third tutorial of Numpy, which is about matrix and vector operation, which is how we can, for instance, do the addition and subtraction between the two arrays. And then in the final section, I will talk about the basic Numpy, how we can do the single value decomposition. And yeah, thank you very much for watching, and please subscribe my YouTube channel if you feel that my video is useful. And thank you very much.